good at CAD and drawing lots of 7.5 meter radius circles, but very roughly, if you draw a 10 by 10 grid, that gives you slightly over coverage when you're using a system. So again, if you're using a normal point detection or spot detection system, this is where you put your smoke detectors on the ceiling. So if you can design that, you can design a Vesda system, because all we're doing with a Vesda system is quite simply joining the dots, and instead of your smoke detector on the ceiling, we've got a hole in the pipework and we're sucking the air down that pipework. It's that simple to design. So I did mention earlier that we can go slightly higher, or quite a bit higher, should I say, than regular detection, but the same height as beam detection. There's a couple of small caveats in that section, which you may be able to, if you've got good eyesight, you may be able to see. Basically saying if we do go to 40 meters, it recommends that we have Class B sensitivity. And I know I haven't spoken about this yet, and I will in a moment, but it basically means a slightly more sensitive system. It also recommends in note 2 in the British Standard that if you are putting detection at 40 meters, it recommends that you have intermediate detection as well, which is obviously a good idea. But just to clarify, it's not mandatory to have that to meet BS compliance. You could just put a system at 40 meters and it would be compliant, but obviously it's better to have intermediate when something's that high, especially if you get something like stratification in that building, which some people might be aware of, where basically smoke hits a thermal layer and fails to rise in particularly hot areas. So just a quick summary, and I say it's not a full design course, but we are available for questions and emails at a later date. If you are designing a system and it is in an electrical data processing area, do consider primary and secondary detection. Obviously, reading the standard will give you a lot more information and guide you on where you need primary and secondary and where just secondary would be advisable. It says there, do not exceed the maximum area of coverage for standard. So to British Standard and Irish, it's 2,000 square metres per detection zone, per fire zone, sorry. Now, there's, as you'll see in a little while as well, there are Vesda systems that can do greater than 2,000 square metres, which is absolutely fine as long as you put it in as a variation. For instance, if you had a very large open warehouse, you might want to push the system a bit further, provided that's acceptable by the client. Obviously, you can do that. Taking into consideration the benefits of multiple pipes. So, okay, if we're using one pipe, it will take longer to respond than using multiple pipes. And again, the pipe calculation software will help you with that as well. It says do not exceed the recommended pipe lengths. Again, this is all done in Aspire, as is, or Aspire or PipeCAD, I should say, sorry, in your pipe calculation software. As is checking the theory of your transport time. Now, just to clarify, your transport time is when you put the smoke into the end or the furthest point on a pipe network. How long it's going to take that smoke to get all the way back to the detector. And that's generally limited to a maximum of 120 seconds. Again, Aspire will calculate this for you. What Aspire will also do is help you with the sensitivity or the correct sensitivity of the device. And again, I keep mentioning sensitivity, and we'll get onto that in just a moment. So, as well as the British standards you're probably fairly familiar with, there's a couple of other standards, and there's something called EN5420, which is an aspirating product standard. There's very similar things for point detection. Point detection, I believe, is EN54 Part 7, and for my days working at BRE, I think heat was EN54 Part 5, but I might have to be staying corrected on that. But basically, all Vesda, all smoke detection equipment is tested. And normally you haven't got to worry about that. All you need to know is it's tested, it's okay for use. But there's a reason why we need to look at that a little bit more detail. There's also the FIA, or Fire Industry Association Code of Practice, which fills in a few of the blanks for aspirating systems, which are in BS 5839 and 6266. The FIA, again, is a downloadable document, and I'm sure many of you are members of the FIA as well. So we'll just get on to why these might be important by investigating what I said earlier.